happening here. I've got a quick sketch of the right-hand branch of the function 1 over x. Goes something like this. We're going to take the interval along the x-axis from 15 to 115 and divide it into 50 equal subintervals. And you might have seen this in your calculus books as delta x equals b minus a over n. That b minus a is the distance from 15 to 115. And if we divide that distance, which is 100, into 50 equal parts, we get 115 minus 15 over 50, which is 100 over 50, or 2. So we're going to get all these little rectangles, well, all these little subintervals, I should say, that have a length of 2. And so these values are going to be increasing by 2. And at some point, we're going to get out here to the 25th rectangle. A sub 25. That's what we want to find, is the area of the 25th rectangle. To find the area of the 25th rectangle using left-hand endpoints, we have to find this value right here so that we can plug it into the function to find the height of that rectangle. And of course, the length of the rectangle is still going to be 2. So how can we find out what that left-hand endpoint is? Let's just try this. X sub 1 equals 15. X sub 2 equals 17. X sub 3 equals 19. Can we get a formula for x sub n? Can you see what we're doing? We're starting at 15 and adding 2. This is like an arithmetic sequence. So we're starting at 15 to get to the nth value in the sequence. We add on n minus 1 differences. And the difference is 2. So this is, distribute the 2, 2n, 15 minus 2 is 13. So 2n minus 13, plus 13, sorry. Let's do a quick double check. When n is 1, we get 15. When n is 2, 4 plus 13 is 17. I think that's it. So that means x sub 25 must be, put 25 in here for n. We get 50 plus 13 is 63. So this value right here, x sub 25, is 63. And if we take that number and plug it into the function f of x sub 25 equals 1 over 63. So a sub 25 is the height of the rectangle, 1/63rd, times the width of the rectangle, which is 2. So the area of the 25th rectangle is 2/63. And of course, we could find the area of any of these rectangles using the same idea. The area of the first rectangle would be, this is still 2, but this is 1/15. So the area of the first rectangle is 2/15, and so on. Okay, so this is leading up to letting the number of subintervals approach infinity and add the areas together and see if we can come up with an area that the total sum approaches as the number of subintervals approaches infinity. But for now, that's your answer.